All right, so this is a graphing unit. We're still staying with logs and exponentials. You should be able to identify something that is logarithmic and something that is exponential. Starting with exponentials. What makes some, and like here we're dealing with functions, which means there's going to be an x and a y. We'll still have an equal sign. What makes it be exponential? Good, the variable, in this case the input variable, the x being in the exponent. So we consider this to be the parent function. You should have already, you should understand the concept of a parent function, which is where you're just doing one thing to the input, but then the concept of applying transformations. What were our transformation values in the past? We've transformed parabolas, we've transformed radicals. What were our values for transfer? Every time we did transformations, what did we, what were the numbers we looked at? H and K, yep. Yeah, A, C, H, and K. A, C, H, and K. And that's going to be the same thing here. He's got to know where to find them. The only thing that's going to change, that changes from parabolas to radicals to exponentials to logs, and I think even later we're going to do absolute value, is just where to find them. So here's where you find A, C, H, and K. I need to give you a pass for advice. Actually, no. Well, you are in my advisement already. So just come the first part of it. Where do we find A? Where do we find A? Like the quicker you answer, the quicker we can get through this. I know we're still half asleep, but I mean, can we? Where do we find A? Where do you see the A located? Before the base, in front of the base. And see, and this is now the challenging thing about logs and exponentials is that there isn't just one parent function. Like they're gonna kind of look the same, but you know, you might have a base of 2, you might have a base of 3, you might have a base of 4, you might have a base of 5. The only real rule is that the base has to be positive. And we'll talk about, and we already kind of did, we introduced it the first day, the different names we give according to the different types of bases. But the only real rule is that the base has to be positive. The H is also going to be up in the exponent with the X, but it's adding or subtracting, and the K is off to the side, either adding or subtracting. The transformations are still in charge of the same thing. A still does vertical stretch and compress. A can still do an x-axis reflection. I put x-axis flip, it's a more layman's term, but C still does horizontal stretch and compress and a y-axis flip. H is for horizontal translations. K is for a vertical translation. Now, something to be aware of. Let's think of some components of the graph, of the graphs that we've transformed. We did parabolas way back in the first semester. What are some things you know about parabolas? At least you tried. Haven, you want to give it a shot? Do you know about parabolas? Yeah, we did it in the first semester. What are some things we learned about parabolas? Just brainstorm. Say it again? Okay, well, that is something we learned, that the domains are real numbers. It doesn't tell me too much about the graph, I guess, like the way the graph looks. But yes, you are correct. The domain of that graph would be all real numbers. Parabola has a vertex. That vertex is located that vertex is located at h, k. Parabolas are also symmetrical, okay, which is what I think you were somehow trying to do with your fingers, Haven, and you were trying to describe with your words, kind of weird, where it has an axis of symmetry. at x equals h right through the vertex. It has vertical symmetry. And then each side, each leg of the parabola is an equal distance from the axis of symmetry. What are some things we learned about radicals? Graphing radicals. We did it not too long ago, like a month ago. We're not talking about rational. We're talking about radicals. It also has a point at h comma k, but now this point is not a vertex. It is a. It starts with end and ends with point. End point, very good. Yes, very good. It has an end point, and it goes forever in one direction. Okay. Exponentials and logs are going to go forever in both directions. They do not have a vertex. They do not have an endpoint. But what they, or at least exponentials, this is going to change for logs. But exponentials, they have a horizontal asymptote. Where else have we seen horizontal asymptotes? The rational ones, yeah, where we had, that's where Victor was trying to describe vertical asymptotes and slant asymptotes. Well, exponentials have a horizontal asymptote, unlike with rationals. Remember where the horizontal asymptote could be, I don't know, for lack of a better word, it could be like violated in rationals. It could be like obstructed. It can go through it. Not with exponentials. When you have a horizontal asymptote for exponentials, it's going to hold firm. Your graph is going to get close to it, but it's not going to touch it. And this is always going to be located at y equals k. The good news also, if you learned something from before, the formula for transformations is exactly the same. Once you've identified a, c, h, and k, we're going to get x and divide it by c, and add h. We're going to get y times a plus k. So that's not going to change. These first few pages of the notes are kind of like a guided study type thing, which to me might even get more confusing. I don't even necessarily want you to do. Oh, this thing is off. Come on. Let's try again. Oh wait, let me do this page, but then we're going to skip a couple pages after that. So the two main types of exponentials. We're starting with exponentials. We'll do logs afterwards, either tomorrow or Monday. Are growths and decays, but you should already know that. Okay. What do growths and decays both have in common? That a has to be greater than 0, because if a was not greater than 0, well, fine. What types of numbers are not greater than 0? Negatives, right? And if a was negative, what would happen? If a was negative on any other graph that we've already done, what happens? What happens when a is negative? Do I need to put the first page back up, or do you have it printed in front of you? What happens when a is negative? Flips how? Yeah, an x-axis flip. So that's all this part is saying, is that, hey, look, as long as a is positive, okay, as long as no flip has occurred, then when the base is greater than 1, we have a growth. When the base is between 0 and 1, also known as proper fractions, the function is called the decay. These are just basic examples of how these look. A growth, as x is increasing, y is increasing. If you've taken like a physics course before, or you plan on taking it, they'll talk about how y is increasing at an increasing rate. So like if this is a roller coaster, not only is it going up, but it's also getting steeper as you go up. That's what a growth looks like before any transformation has occurred. Okay? Wherever wherever K is, you'd have a horizontal asymptote. A decay, it's like a roller coaster where it's decreasing, but also at a decreasing rate. It's getting flatter until you reach your asymptote. Okay, and this is tells you the same thing we knew before. We have a horizontal asymptote. If you get asked about, what is this? Oh, if you get asked about end behavior, as I told you, in how many directions does an exponential go forever? It goes forever in two directions. Okay, so on a growth, as you go to negative, as x goes to negative infinity, which is just another way of saying left. If you know this, great. Like, I don't expect you to have to write this if you know this, but especially some of you that still never really understood, that sound I hear right now is you actually writing this stuff down and not just counting the minutes until class is over. When x is going to negative infinity, that means left, right? On a growth, what is the left arrow doing? Not just going down, but going down towards where? No, not going down towards where? The asymptote. So that's why it says f of x, because we know the asymptote is going to be at k. What is the right arrow doing on a growth? So this means right. Okay, x going to positive infinity means the right arrow. Where's the right arrow doing? Going up to positive infinity. On a decay, what is the left arrow doing? It is going up to positive infinity. This is assuming that no transformation has occurred. And then what is the right arrow doing, Caitlin, when? Going down to where? Negative. You weren't listening 30 seconds ago. Sunshine, how about you? What's the right arrow doing? Going down to the asymptote, which we already know is at k. All right, so these next few pages, you can try to do them on your own later. I just kind of have these here just in case. I'm going to try to give you kind of a direct, oh, look, here, do you have those answers there already written in? Those are written in for you? Oh, man, I forgot I didn't erase them. All right, well, whatever. All right, let's start here. And you know what? Let's do this. Let's change the instructions because I believe that they're going to add these to the test. So let's find both x-intercept and y-intercept. And then let's also determine if we have a growth or decay. This first one here, is this a growth or a decay? Why is it a decay? Don't say it. What is it? Thank you. The base. The base, which is what is directly underneath the fraction, the exponent, is a proper fraction. So this would be a decay. Now here's a trick question that they love to give you. So I'm warning you now. When you get tricked by it later, don't say I didn't warn you. If for some reason this is negative, if you see it like a negative in front of the x, it's the opposite. Because think about it. What does a negative exponent do to its base? Huh? It does not change the sign. What does a negative exponent do to its base? The reciprocal. It flips it. So if that x would have been negative, and they love to do that, you're like, oh yeah, that's a decay. But then if it's negative and it flips it, now it becomes 5 over 3. 5 over 3 is greater than 1. It'll be a growth. Don't say I didn't warn you. So this is a decay. Now let's find the intercepts. Let's just do this algebraically. X-intercept and y-intercept is where we would touch the x and y axis. What do all points on the x-axis have in common? Y is 0. What do all points on the y-axis have in common? X is 0. Okay? Now, of these two, you're going to like y-intercept better. But let's just, yeah, you know what? Let's do that first. Let's find y-intercept first. So for the y-intercept, x is 0. So we would say then that y is equal to 12 times 3 over 5 to the 0 power. What's anything to the 0 power? It is 1. So basically it cancels out because what's 12 times 1? 12. So in summation, where can you find the y-intercept on an exponential? Huh? At A. Now just be careful. This is assuming that there is no other transformation, that there is no C, no H, no K, because that could change things. But assuming all you have is an A, that's where you're gonna find the y-intercept. How could you find it for sure? Just plug in a 0 for x. How about the x-intercept? How would I find the x-intercept? Put a 0 for y. And let's see who actually learned something. Because now the variable that we're solving for is in an exponent, what are we going to eventually need? We're going to need a log. And whoever said divide by 12, that is correct. What is 0 divided by 12? Still 0. So we get 3 over 5 to the x. We would just take log base 3 over 5 on both sides. I believe this is not, this is going to give you an error. Put log 0 divided by, because if you put log 0, you're going to get an error. You can't take anything to a power and get 0. Okay, so that means we're not going to touch the x-axis. Why do you think we wouldn't touch the x-axis? Very good. That's where the asymptote would be. Since I already taught you that the asymptote would be at k, and you don't see a k is 0, it's right on top of the x-axis. We're not going to touch the x. This is probably not the best example to show you x-intercept, but I overheard the person who's making the quiz and the test say that they were going to add these, so that's why I wanted to throw in x-intercept. Is that a growth or a decay? It is a growth. Why a growth? The base, I can't write. The base is greater than 1. Right, Mohammed? Mohammed is all about that base. How do we find the y-intercept? Yeah, put a 0 in for the x, but as you saw before, anything to the 0 power is just 1. So you end up with just the value of a. Yeah, that's what I said the last time, yep. But I also want to see, this might be surprising to you, but I'd venture to say somewhere between 33 and 50% of you right now your eyes are communicating with your hands and somehow bypassing the brain entirely. It's amazing. Like you can be here physically and not be here mentally. So what happens is I like to show it algebraically, because then later on you'll go back and studying it when you are coherent, and at least it forces you to see how to do it algebraically. If I were to just put, hey, look, it's 0.25, then you're gonna forget how I got that. Just saying. For you, Randy. Alright, so 0 equals 0.25 times 2 to the x. As we said before, once we divide by 0.25, we get here. And then once we take log base 2 on both sides, you're going to get an error again. And as I'm sure Musi's about to point out, the reason why you get an error is because there is no x-intercept. And the reason why there is no x-intercept is because if we were to actually graph this, you would see that since k is 0, since there's no k, there's a horizontal asymptote there. You can't touch it. All right, fine. Um, I just want to show you how to do it differently, but just try to pay attention. All right, is this a growth? Look, this is a parent function. There's like here, let's identify what's A here. 1, because in front of the 5 you don't see multiplication. What is C here? A is what's in front of the base. C is what's in front of the X. What's in front of the X? A 1. No, please don't say a 5. It's a 1. Okay. H is whatever is up in the exponent being added to the X. There's nothing. K is also 0. So like really, if I wanted to, I already know that you're the man, Chase. We're going to have a horizontal asymptote. Now, here's why I was kind of like fidgeting a little bit. Well, first of all, is that a growth or decay? This is a growth. The base is greater than 1. So I know this is going to somehow take like that type of a shape, but I'm not going to just randomly sketch it like that. So the reason I was kind of fidgeting is because I'm pretty sure like any other teacher is going to just teach you how to plug in X's, and get Y's. And that's kind of what I'm going to do, but I just want to show you how to write it a little bit differently. Here's what I would like. Okay? I'm going to use a table. I'm going to use a table. I'm going to use a table for the parent function. Like once we start getting into transformations, I'm going to use a table for the parent function. I'm not going to use a table for the final transform one. Because even if it's a growth, every growth is going to look slightly different because the base might be different. Every decay might look slightly different because the base might be different. So I'm going to use a table just to come up with a set of parent points. But then after that, I'm going to transform them. My recommendation, this is definitely you're going to want to write this down. Hey, domain boy, what is the domain of an exponential function? All real numbers, sure. It goes forever left and goes forever right. So as far as the x's that you can pick whatever you want. Here's my recommendation. For a growth, pick 0 and positives. For a decay, pick 0 and negatives. It's going to give you the best definition on the curve. For a growth, why do you think you always want to pick 0? Why is 0 awesome? Because it's 0 is just cool, you just like it. Because since this is exponential, what is anything to the 0 power? Yeah, it's 1. So that's why I always start with 0. So this is a growth. I'm going to pick 0 and positives. 5 to the 0 is 1. 5 to the first is 5. 5 squared is 25. And yeah, 125. And this is a terrible graph because it's not going to fit much. Oof. Yeah, I'm gonna have to scale it then. What do you think? Yeah, we're gonna have to scale this. What do you think would be a good scale here? We're not gonna get to the 125. Like we'll just do. Look, this is similar to radicals. I would love to graph 4 points here, but if you do 3, 3 will work. I'm gonna do 5s. Yeah, very good, Musi. I'm gonna do 5s. So if I were to do 5, that would make this 25. That would make this 50. And then you can just ignore these other numbers here. I don't have to change. I don't have to change anything else. But before I can graph, I need to transform. The thing is this graph going to be transformed at all? No, anytime A or C are 1, it does nothing. Anytime H and K are 0, it does nothing. So I'm actually just going to plot these points. And I'm scared that's going to start confusing people, but all right, whatever. So we have a point at 0, 1, which is going to be down here because we're counting by 5s. At 1, 5, which would be here. And then at 2, 25, which would be here. Make sure you don't touch the asymptote. And it would look something like that. What is the domain? The domain of any exponential is going to be all real numbers. That's not going to be the case for logs. I don't know when we'll get to logs, but that's not going to be the case. But for exponentials, always all real numbers. What's the range? It depends on where you are relative to the asymptote. You're either going to be all above the asymptote or all below. Since in this case we're above, the low end is going to be the asymptote. We don't touch it, so it takes a parentheses. In radicals, you would touch that minimum or maximum, but here you don't. And this is at 0 to positive infinity. And where was that asymptote located? But since it's horizontal, you have to put y equals 0. End behavior. Maria, what's the end behavior? It's okay, at least you tried. Gabby, what's the end behavior? See, hold on. Even if you know nothing about end behavior, right? And this is why I still say, as much as, oh, but math is too hard, I don't get it, it's too hard, blah, blah, blah. Like I even heard like my kids in credit recovery on this last unit saying how logs are so hard. Logs, yeah, fine, maybe, but you know what? As much of a math issue, it's just a paying attention issue. Because even if you know nothing about end behavior, if you know nothing, I know that here I'm going to put a negative infinity, and here I'm going to put a positive infinity because I want to know what's happening on the right side. I want to know what's happening on the left side. Assuming you have arrows, and I have 2 arrows here. Now, Gabby, I could ask you, what is the y going to do as x is going to negative infinity? It is not going to negative infinity. What is the left arrow doing? Go ahead, Chase. It's going to the asymptote, which is k, which is 0. This left arrow, it is going down, but it's stopping at the asymptote. Zora the Explorer, what's the right arrow doing? To where? Where is it headed towards? Oh dear. Thank you. Okay, apology accepted. Huh? No, horizontal lines are y equals 0. Vertical lines are... When did I say we were going to go over the test? Or Monday. Yes, true, you were in the potty. Last question. Were there any transformations done to this graph? And I'm going to put a big fat no to try to get your attention because that's important. Because if there would have been any transformations, it would have been more work. It would have been more work. How can we tell? Really, because A was 1, C was 1, H is 0. You think of these as like the defaults. If any of that is true, then you can ignore those. If A is 1, you can ignore it. If C is 1, you can ignore it. If H is 0, you can ignore it. And if K is 0, you can ignore it except for the asymptote. You got to know where the asymptote is. Ooh. All right, so let's do this. Let's put up here parent, and then this is gonna be transformed. So like think of these as like our beginning points on the left and our final points on the right. Is this a growth or a decay? It is a growth. So on my parent, I'm going to pick 0 and positives. Okay, also I need to identify A, C, H, K. What's A here? Okay, A is in front of the base, and up here there's nothing being multiplied, so that's just a 1. What is C? C is in front of the X. Please don't tell me it's a 3. Yeah, there's no coefficient in front of the X, so C is 1. That's also why you don't see a parentheses up there. What is H? 2. Remember, in every other transformation we've done with H, you got to change the sign. So H is going to be positive 2, and what's K? What's K? 0. So what is the only transformation that's going to have an effect here? The H. And on the formula that I gave you, what does the H do? H is not horizontal asymptote. Oh, horizontal. Oh, I'm sorry. They said, sorry, man. Sorry. My bad. Yes, it does do horizontal translations, but how do I apply the horizontal translations? How do I apply the horizontal translations? I added 2. You want me to go back to that page, or you want to just look in front of you in the notes I printed out for you? What do I add H to? All the x's. Thank you. Add it to all the x's. Let's just go ahead and get the y's already. Now, see, this is a base 3 exponential, so now I'm taking 3 to these powers. 3 to the 0 is still 1. 3 to the first is 3. What's 3 squared? What's 3 to the third? 27. Let's change this to 3's. Let's scale this to 3's. So then this would be 15, and that would be 30. I think that'll work well. So this would be 3, 6, 9, 12. You don't have to write every single one. On this one I will, because if not it'll get confusing. 27. So if you remember, we used coordinate notation before. So like we're starting with 0, 1, 1, 3, 2, 9, 3, 27. And I need to go to all the x's and add what? I'm adding 2 because h is 2. 0 plus 2, comma 1. 1 plus 2, comma 3. 2 plus 2, comma 9. 3 plus 2, comma 27. I didn't have to touch the y's because a was 1 and k is 0. What is 0 plus 2? So I'm going to have 1 point going to be at 2, comma 1. 1 plus 2 is 3, so 3, comma 3. 2 plus 2 is 4, so 4, comma 9. And then 3 plus 2 is 5, 5, 27. Where is my asymptote going to be? At y equals 0. Don't forget the y equals. You're going to lose points on a quiz, and then you're going to say I'm the bad guy. Which I know I am the bad guy, but just don't like it when you say I'm the bad guy. It's y equals 0. So now let's plot our points. 2, comma 1. 2, 1 would be like here. 3, 3. 4, 9. And then 5, 27. Don't cross the asymptotal. There's your growth. So notice how the basic shape of the growth, even though we had different bases, on the one we just did before, we had a base of 5. Here we have a base of 3, but they look roughly the same. The only way to really tell the difference is to go look at the actual points themselves, but they both look like a growth. What's the domain, Caitlin Hall? Easiest question of the day. Good. Very good. Negative infinity positive infinity. That's the case for every exponential, but whenever we get to logs, that's not going to be the case anymore. Shina, what's the range? If you can't get it, Kate's going to start waking up so he can help you too. Kate, you want to help her? What's the range? Yeah. We've been doing domain and range since 9th grade. You can help Kate with a swing or with range. Dennis, I think Dennis could also help Kate. Because it's range. I mean, I could have asked you this back in October and you would have been able to do it. It's just how low and how high does it go? Thank you, Randy. You just stole his glory. It was his moment in the sun. All the ladies were watching him, and you just came in and stole his thunder. Tommy, yo, Tommy. Asymptote. Where's the asymptote? You're the man, Tommy. Okay, Maria, here's your chance to totally redeem yourself. And behavior. Okay. As x approaches negative infinity, then y approaches. It does not. As x is going to negative infinity, which is the left arrow, we are not going to positive infinity. Huh? Thank you, Dennis. But K, where's K at, Dennis? What number? It says it on the page. Yeah, there you go. Hey, Steph. No. Oh, birthday girl. I haven't even called on birthday girl. Come on, birthday girl. What's the other part? Yeah, positive infinity. Yep. The right arrow is going to positive infinity. We already answered the last question. We answered at the top. Is that a growth or a decay? It's a growth. Fax machine. Ooh. Mohammed. Is this a growth or decay? It is a growth. I don't know why they have so many tables here, but yeah, maybe. I don't know. Maybe that's why. Now this is also a base 3 growth, so at least the parent function is going to be the same. I can use 0, 1, 1, 3, 2, 9, and 3, 27. What's A? It is 1. What is C? 2. What? It's still 1. In front of the X is a 1. What's H? Negative 1. Good. What's K? Well played. I already know that this is going to now have a horizontal asymptote at y equals negative 2. But now I got to conduct all these transformations. I guess they wanted you to use tables. I guess I can do them on the here. So let's do this is the parent up here. This will be the final transformed, and just because I don't have that much space, it's going to be yucky, but let's try to use the table. What are we going to do to each of those points? We are going to subtract 1 from the x's. All the x's are going to be minus 1 because of h, and take 2 away from the y's. So we go 0 minus 1, 1 minus 1, 2 minus 1, 3 minus 1. And then 1 minus 2, 3 minus 2, 9 minus 2, 27 minus 2. Whatever the heck you want. I mean, the only thing is before I wrote them in coordinate notation with the parentheses, but now I just went with the table because it was there. How does that make you feel? Like I mean I actually prefer you make it look like this, like coordinates. I just think it's less work than having to draw a table, but when in Rome, do as Randy does. So this is what I need to plot here. What would be, you think, a good interval? Let's leave it at 1, and we just won't graph the 225. Let's just leave it as is. So the first point, -1 would be right here. Then 0, 1 is up there, and then 1, 7. Yeah, I think that's good enough. Looks like a growth, so that's good. Anita, what's my domain? Awesome. China, range. Good, yeah, it's above the asymptote, so 0 to positive infinity. Meredith, asymptote. Say it better. Good, y equals -2. Thank you, you're right. If I had candy, I'd give you one. You know, I do have chips. I'm going to bring in chips. Sorry, yes, good point. Thank you. The asymptote was at -2. Whatever k is. Whatever k is. Wherever k is, that's your asymptote. Now, again, disclaimer, once we get to logs, it's going to change. It's going to be a logical change, but it's going to be, no pun intended, logical. Why are you drinking in my classroom? So, come on, Maria. Let's do it, Maria. I'm going to help you out. Negative infinity, positive infinity. Where's the negative infinity y going? Where's the left arrow going? Shush. Maria. Dennis, stop it. Now, Big Vic, left arrow. What was the color of George Washington's white horse? It was -2. Good. No, it was -2. And then Calvin, what's the right arrow doing? Good. Positive infinity. Let me see the next one. Is that one long? All right, let's do this for tomorrow. How many more do we have left? All right, so the way it's looking, I'm looking at probably the test on Monday because I wanna keep this going. So we'll do all day tomorrow, and then I'll get back to test Monday. No, we're not gonna take a test Monday. I mean, I'm gonna give back the test Monday. What? I think 2 people got 100, 2 or 3.